The space between the stars is not empty. Right now, with no sun to warm them, more planets drift through that darkness than there are stars in our galaxy. Worlds thrown out of wherever they were born, frozen solid and moving at kilometers per second while giving off almost nothing we can detect. One of them could be falling toward our solar system as you read this, and we would have no idea. That's the reassuring version, because the harder we look at our own cosmic backyard, the more we find that the things pulling on us hardest are the ones we can't see at all. Let's go find them. Here's the thing worth sitting with. Almost everything we know about the universe, we learned because it gave off light. Stars shine, gas glows, and dust reflects, so we built our entire map of the cosmos out of things that throw photons into a telescope. It's a beautiful method, and it's completely blind to anything that stays dark. Most of the universe stays dark. Finding something that gives off no light takes a different trick, the same one nature has used since the beginning, which is gravity. Mass bends space, and light has to follow the bend. Einstein worked this out in 1915, and by 1936, he reluctantly published the specific consequence: that a massive object passing in front of a distant star acts like a lens and briefly brightens the light coming from behind it. He assumed it would never be useful, and he was wrong. We call this gravitational microlensing, and it works like a flashlight in the dark. When an invisible object drifts across the line between us and a background star, that star flares up for a few hours or days, leaving a gravitational fingerprint from something we will never photograph. That's one way to find the unseeable. The second way is older, and it's how we found Neptune before anyone had aimed a telescope at it. You watch how the visible things move, and if a planet's orbit gets tugged in a direction nothing accounts for, then something out there is doing the tugging. The math betrays the intruder long before the eye ever catches it. So we have two tools: microlensing for the wanderers passing through, and orbital dynamics for the things lurking and pulling. Keep both of them handy, because we're about to hunt 3 different kinds of monster, and every one of them is invisible. Let's start with the wanderers. For a long time, we assumed planets stayed home, bound to a star and tracing tidy ellipses the way Earth does. Planet formation is violent, though, and young solar systems behave like demolition derbies, so when worlds gravitationally shove each other around, some get flung out completely and exiled into interstellar space. We call these rogue planets, and the old models treated them as a rare accident. The old models were badly wrong. Microlensing surveys and the newest space telescopes now put the count somewhere between 10 billion and 100 billion of them, with some estimates climbing toward the trillions, ranging from 1/10 of Jupiter's mass up to 10 times it. There may be more starless planets drifting through our galaxy than there are stars inside it. The dark isn't the gap between the interesting things. The dark is where most of the planets actually live. For years, this stayed a matter of inference, populations you could calculate but never touch. That changed in January 2026, when researchers used microlensing to measure the mass of a single rogue planet directly for the first time. Coming in around 1/5 of Jupiter, roughly the mass of Saturn, a real world confirmed alone out in the freezing black. Not a model, but an actual measurement. We're about to get greedy too. NASA's Nancy Grace Roman Space Telescope was built partly for exactly this hunt, and predictions worked out by researchers like Koshimoto suggest it should catalog on the order of 100,000 transiting planets and directly detect around 400 Earth mass rogues. Mireille Roig and her colleagues have already turned up between 70 and 170 new free-floating planets inside a single young star cluster called Upper Scorpius in one survey. We're about to switch on the lights in a room we always assumed was empty and find it packed. Wandering planets passing in the night are the tame threat. The unsettling one might already be here. Out past Neptune, in the frozen swarm of debris we call the Kuiper Belt, the orbits are wrong. A cluster of distant objects, the trans-Neptunian objects, trace paths too tilted, too stretched out, and too neatly aligned to pass for coincidence. Something out there is hurting them. Konstantin Batygin and Mike Brown made the famous case for a hidden 9th planet, 5 to 10 times the mass of Earth, orbiting somewhere between 400 and 800 times farther from the Sun than we are. We've been hunting Planet 9 for years. Here's the trouble with that. We have looked hard in optical light and in infrared, and we still haven't found it, even though a world that big should be easy to catch. That absence is where the story turns strange, because a group of Harvard researchers pointed out that the gravity hurting those objects doesn't actually need a planet. It just needs a mass. One other thing can carry 5 to 10 Earth masses while giving off no light whatsoever, and that thing is a primordial black hole. Let me be careful here because this claim deserves candor. Primordial black holes are hypothetical objects that, if they exist, formed not from collapsing stars, but from density fluctuations in the first instance after the Big Bang. Tiny knots where the infant universe ran slightly too dense and pinched itself off into a hole. We have never confirmed a single one. Run the numbers though, and the picture sticks with you, because a black hole of 5 to 10 Earth masses would have an event horizon about the size of a grapefruit. Picture a bowling ball of pure darkness orbiting our sun in total silence, invisible to every telescope we own, quietly rearranging the outer solar system. So we're left with two suspects: an ice giant we simply haven't caught yet, or a fossil from the birth of the universe hiding in our own backyard. Most astronomers still bet on the planet, and Batygin and Brown remain unmoved. The longer the infrared silence drags on, the longer that grapefruit stays on the table. There's something clarifying about the standoff, because we cannot yet tell the difference between an undiscovered world and a leftover scrap of the Big Bang. From the outside, gravity is just gravity. The tug tells you the mass, but it never tells you the monster. The mystery keeps going past the edge of the Kuiper Belt. Travel much farther out to the Oort Cloud, the vast, spherical shell of icy debris that wraps our solar system and stretches something like halfway to the nearest star. It's the most remote real estate we can claim, so distant and so dark that it goes almost entirely unobserved. And computer simulations suggest it may not be empty either. The result those simulations produce is unsettling. When a rogue planet goes drifting through the galaxy, one of those trillions, and it happens to pass close to a star system, it doesn't always keep going, because sometimes it gets caught. The models put the odds that our own Oort Cloud has already captured a wayward exoplanet, something close to Neptune-sized, at around 7%. That's not large, but it's a long way from nothing. A 1 in 14 chance that an entire alien world, thrown out of some other star and adopted by ours, sits out there in the deep freeze right now, uncatalogued. A guest that size does not sit quietly. The Oort Cloud holds billions of comets balanced in the faintest gravitational equilibrium, so a massive intruder wading through them scatters those icy bodies like a boot through gravel. Some of that gravel gets flung inward and becomes the long-period comets that come screaming down into the inner solar system on million-year timescales. The threat in the dark isn't only the thing you can't see, it's whatever that thing kicks loose in your direction. Step back and notice what all three of these share: the trillions of rogue planets, the grapefruit that might be Planet 9, and the captured world hiding in the Oort Cloud. None of them shine. Every one of them was found, or suspected, not by looking, but by feeling for the bend and the pull that mass leaves behind in the dark. We spent centuries assembling a picture of home out of the things that glow, and it turns out the glowing things were never the whole story. They were the exceptions, the lit windows of a house whose rooms are mostly dark and mostly occupied. The Nancy Grace Roman telescope is about to open its eye on that darkness and start counting what's actually there. Some of what it finds will be 400 lonely worlds, and some of it will be stranger than that. The quiet lesson underneath all of it is the one worth keeping, that the universe never owed us the courtesy of being visible, and we are only now learning to read it by touch.